Hello everyone, I hope you're doing well and welcome back to this training course. This is part 23 and in this session we will be discussing how to implement in the AS BGP MPLS VPN option C on Nokia routing devices. We know that we have three options, option A, option B and option C. In the last two sessions, we've already demonstrated to you how to implement in the AS BGP MPLS VPN option A and option B. We know that these two solutions, they are not scalable enough for a service provider network. And that's why we have in the AS BGP MPLS VPN option C that is more scalable and most preferred for a service provider network. Remember, when we are setting up a service provider network, you need to implement solutions or design that are more scalable and even flexible, because the service provider network will keep growing. You will keep increasing the number of sites. You will keep connecting to new customers. So you need to implement a solution that is more scalable and flexible. That's why in this session, we will be demonstrating to you how to implement in the AS BGP MPLS VPN option C on Nokia routing devices. When it comes to option C, it may be complex in configuration and the operations, but it's more scalable compared to option A and option B. Remember, in option A, we normally call it VRF to VRF communication because we will be doing VRF to VRF peering for the different VPN instances between the SBRs, which makes it not scalable enough, especially when you have so many VPRNs configured on your network. With option B, we will be doing VPN v4 peering between the ASBRs. But with option C, now we don't need to establish the VPN v4 peering between the ASBRs. Instead, we will be establishing BGP VPN v4 peering session between the PEs directly. Remember, in this setup, we have P1, we have P01, we also have SPR01 in AS65001. We have a similar setup in AS65002, we have SBR2, we have P02, we have P02, which is connecting to C02. For the BGP configurations, we need to establish BGP label unicast between the PEs and the SBRs. We will also establish BGP label unicast between SBR1 and SBR2. And then we'll go ahead and implement BGP VPN v4 peering session between the PEs. The PEs will be able to exchange VPN routes directly with each other, making it more scalable. A better solution will be having a route reflector in a 65001 and also in a 65002, and then we will establish BGP VPN v4 peering between the route reflectors. That will make it more scalable and more adaptable for a service provider network. For the configuration steps, we are doing almost similar configurations, starting with the basic interface configurations. So we need to do the interface configurations. We need to do IGP configuration. We need to configure MPLS and LDP, and then we'll go ahead and do BGP configurations and complete with the VPRN configurations on these nodes. So let's start by doing the basic interface configurations. So for the interface configurations, we are doing the port configurations and configuring the interfaces on these devices. Remember, when you are configuring the port towards the provider edge router, you need to configure it as mod hybrid because we'll be using a VLAN on that interface. And then you also need to enable the link layer discovery protocol, which is LLDP, that will help us to tell which device is connected on the remote side of this local equipment. And then we configure the interfaces. So on C1, we need to configure the system interface, which will be the management interface for this device. And then we'll do similar configuration on all the other devices. So let's start by configuring C1. I'm logged into these devices here. So we'll start by C1. Again, we've already discussed these basic configs in the previous sessions. So you may need to go through the previous sessions to help you understand each command that we are using for these basic configs. So let me start with C1. And then on P1, we are doing the same. We need to configure the system name. We need to configure the ports. We have a port connecting to C1. We also have a port connecting to P01. So you configure these ports, you enable LLDP, and then you also need to configure the interfaces towards PE01. This is the interface towards PE01 and the system interface. When you are doing this configuration, you always have to give the correct parameters, the correct port, and the correct IP address that you've assigned in your design documents. So I'll copy PE01 configs, paste them here, and then we can do similar configs on P01. So P01, we are also doing the interface configurations. Remember, it's connecting to P01 and SBR01. So let me copy these commands. These are just basic interface configs. And then on SBR1, we are doing the same. We need to configure the interface facing P01 and SBR02, and also activate LLDP on these interfaces. So remember, on Nokia, we have the interfaces configured as kind of logical interfaces, but you always have to bind the physical ports on the interfaces. On SBR2, we'll do the same. Go to SBR2 and do the configurations. And then on P02, you also need to configure the ports and the interfaces facing SBR2 and P02. Next, we configure P02, which is connecting to P02 and P02. And then we can configure C02. So for C02, we will run these commands, the port configuration and interface configuration for the system interface. So once you've done this, you can do the verifications. For example, you can show ports. You want to check the port status, are our ports up? Those are some of the basic checks that you need to perform. So you see that we have port 111 and 112, they are up. And then you can also show a specific port. For example, show port 1/1/1, and you'll be able to see a lot of parameters that have been configured on that port. We can check the LLDP. So show system LLDP neighbor to verify that we are connected to the correct equipments. You will see that port 111 is connected to CE01, port 112 is connected to P01. You can also check the same, show system LLDP neighbor. We have SBR02 connected to SBR01 and P01. On P02, you can also verify, show system LLDP neighbor. So we are doing this basic verification so that we don't do all our configuration and then we realize we are connected to the wrong equipments. We've done wrong configuration on wrong equipments. So we can do these basic checks as we do the configuration so that we are able to fix the issues as we go. So you can also check the router interface, show router interface. You'll see the interfaces configured on these equipments. You can also show the details, show router interface detail. It will give you more information about the interfaces configured. We can also do ping tests. So for example, on P01, if you show router interface, you'll see that we have multiple interfaces, one to SBR1 and another one to P01. We can do a ping test to just confirm that we've configured the correct parameters. So the other side should be .3. You see that it's reachable, and then .0 is also reachable. So this confirms that we have done the correct basic configuration for these devices. Once we've completed the basic configs, we'll go ahead and implement IGP in these ASs. So we have AS65001 where we'll be implementing OSPF, and in AS65002, we will be configuring ISIS. Remember, when you have two different autonomous system numbers, you can configure different IGPs because they will not be interacting. You can use OSPF in both. You can use ISIS. You can use any other protocol that is supported as an IGP. So in a 65001, which has PE01, P01, and SBR01, we will be configuring OSPF just to give us reachability between these different nodes. Remember, it's always good to have reachability before you can start doing things like BGP and MPLS. So for OSPF configuration, very straightforward. You need to configure OSPF process. We are configuring OSPF process 10. You need to configure the router ID. The router ID, this is the system IP that has been assigned on this node. And then you configure the area and activate the interfaces in these areas. So I'll start by configuring PE01. So on PE01, I'll do exit and then configure OSPF. On P01, we do the same. Just ensure that you configure the correct router ID and activate OSPF on all the relevant interfaces. So on P01, I'll paste those commands, and then on SBR1, we also configure OSPF on this router. Once we've completed our OSPF configurations, we can do the verifications. We do show router OSPF 10 neighbor. You see that we have an adjacency established to P01. On P01, show router OSPF 10 neighbor. You expect to have two neighbors, to P01 and to SBR01. You can show router OSPF 10 interface to show you that we have three interfaces activated with OSPF. You can check the DB, the LSDB. You will see that we have the LSS. They are all router LSS because these routers are in the same area 0. You can show router OSPF 10 routes, verify that our routes are propagated across the different nodes. You can also check the routing table, show router route table. If you do, you can choose to give protocol OSPF so that you only see the OSPF routes. And you can see that we are getting the loopback IPs of PE01 and SBR01 through OSPF protocol. Finally, we can test the ping. So ping 1.1.1.2, it's reachable, and then ping 1.1.1. This is .4. which will also be reachable through OSPF. On P1, we can verify that if we do ping 1.1.1.4, we should also be able to reach the loopback IP of SBR01. So this one confirms that our OSPF implementation is okay. We can now go ahead and implement IGP in a 65002. So in this AS, we are using ISIS as our IGP. Remember, OSPF and ISIS, they are both link state protocols. And we can choose to use either in any of the ASs. This is just to also help you understand how to configure or remind you how to configure ISIS or Nokia routing devices. So when you are configuring ISIS, you also need to configure ISIS process. You need to configure the router ID. You need to configure the level capability. Remember, we have different levels, level 1, level 2, and level 1, 2. In this case, we are using level 2. Then you need to configure the area ID. Remember, in ISIS, we have the network entity, which is very important when implementing ISIS. So you need to configure the area ID, and then you can activate ISIS on the interfaces. You configure the interface type, point to point. You also configure the level capability on these interfaces. So let me copy these commands and configure on SBR02. So I log into SBR02 and apply the commands. Then we can do the configurations on P02. So on P02, we need to activate ISIS on the system interface. We also need to activate ISIS on the interface towards SBR02 and to P02. So let me copy these commands and do the configuration on P02. Finally, we need to do the configuration on P2, and then we can do the verification. So on P2, exit and then apply. So once we've done these configurations, we can do the verification. Show router ISIS10 adjacency shows you that we have two adjacencies on this router as expected. One to SBR02, another one to P02, P02. And then you can check the interface, show router ISIS10 interface. You can also check the DB to show you that we have the LSPs. You can check the routes. So you do routes, it will tell you that we are having these ISIS routes. You can check the routing table, show router, route table, protocol ISIS. You can see that we have these two ISIS routes. You can try to ping so that we confirm the reachability between the different nodes. .7 also reachable, so that is okay. From SBR02, we should be able to reach the loopback of P02. So this confirms that our ISIS configuration in these AS are okay and everything is working as expected. The next step of configuration, we need to configure and enable MPLS and LDP on interfaces in our MPLS backbone for both AS65001 and AS65002. So for these configurations, remember MPLS, LDP. LDP will be used as the signaling protocol. You can choose to use RSVP. You can choose to use any other protocol that is available to you. In this case, we are just using MPLS and LDP in this lab setup. So we've already discussed these MPLS configurations. So we'll just go ahead and copy them and apply them on the devices, starting with P01. One thing that you need to remember is you need to activate MPLS and LDP on all the interfaces in our MPLS backbone. If you forget on one of the interfaces, you will have disconnect in the network. So it's always recommended that you confirm or verify that you've applied this configuration correctly on all the equipments or all the routers in your network, in your MPLS backbone. So we'll do P01, P01, same commands, just changing the interface that we need to activate these protocols. And then on ASBR01, we'll copy these commands, go to SBR01 and apply them. On P02, we do the same, configure MPLS and LDP. On P02, we also implement MPLS and LDP. And then we can go ahead and implement on SBR02. So on SBR02, we'll copy the commands and configure them as planned. So you can do the verifications. You can run show router MPLS interface. Example on P02, show router MPLS interface. Will show you the interfaces that you've configured MPLS. You have the system interface, you have to SBR, you also have to P02. You can show router LDP session. Remember, LDP will be used as the signaling protocol. This is called the label distribution protocol. So you can see that we have sessions established on these routers. On P01, you can also verify show router LDP session, which gives you that we have session established towards P01 and SBR01. You can also check the LDP bindings, show router LDP bindings, so that you are able to see that we have the bindings, the labels assigned, and many other details that you can check when you are configuring these protocols on Nokia routing devices. So once we've done these MPLS and LDP configuration, the next step is we now need to configure BGP LU. Remember in option A, we were using BGP VPN before peering between the PE and the SBR. In option C, we are configuring BGP labeled unicast so that these devices will be able to exchange labeled routes between them. So we need to configure BGP LU between PE01 and SBR01 and also PE02 and SBR02. When you check these commands, they are similar commands that we've been configuring on many of these devices. You are creating a group, of course, you configure the router ID, next hop resolution, you want these routers to be able to resolve the routes. And then for the family, you need to ensure that this is labeled IPv4, which will help us to establish BGP label unicast peering in S65001 between PE01 and SBR01. So you need to ensure that you activate this label IPv4 family. And then we have a policy, the BGP-LU export. You have configured the autonomous system number as expected. You've configured the router ID. So these are commands that you need to verify and ensure that they are the correct commands for these connections. So on P01, I'll copy these commands. Go to P01 and configure them. And then on SBR01, I also need to do the configurations. So on SBR01, I'll apply the commands. I'll go to PE02. Remember, you also need to establish BGP label unicast between PE02 and SBR02 for them to be able to exchange label routes. So on PE02, I'll run these commands. Go to SBR02 and also apply the commands to help us to activate label unicast between these devices. So once you've run these commands, we can do the verification. For example, show router BGP summary. When you run these commands, you can see that we have label IPv4 session established between SBR02 and PE02. You can show router BGP group. These are just some BGP commands that you can run. And you can see the details. It's telling you that we have list of static peers established. This is one. And then you can also show router BGP neighbor. Show router BGP neighbor to see more details about these sessions established between these different devices. You can see that local family label IPv4. Remote family is also label IPv4. So once you've done this verification, you can also verify on P1, show router BGP summary, and you will see that we have label IPv4 session established between PE01 and SBR01. So that confirms that we have label unicast session established between the routers. If you are to check the routing table, you will realize that we don't have any routes. If I log into this router, show router BGP routes, and I do label IPv4, you will see that we don't have any routes. Remember, BGP does not discover routes. We have to put routes into BGP before the routes are advertised between neighbors. So what we'll do is we now need to advertise system IPs of PEs to the SBR. Remember, the goal is to have VPN v4 peering established between the PEs. And VPN v4 peering will be established using the system IPs. For these system IPs to be reachable, we need to advertise them from the local PEs to the local SBRs, and also from the SBR to the remote SBR, so that the routes can be propagated to the remote PEs. So this is what we'll be doing on this device. If you have implemented the other protocols, you realize that if you have implemented the other BGP options, we don't need to propagate these system IPs to the remote PEs. But with option C, we need to do that. If you are using a route reflector, you will also need to do the same. You need to propagate the IPs of the route reflectors towards the remote SBRs and also towards the remote route reflectors. So on this device, we need to advertise 1.1.1.1.2, which is the system IP of P01, and we are using a policy to help us control what we want to export from this device or to advertise from this device to the remote devices. So you can see that we are creating a prefix list, and then we have the BGP LU export policy that we've created. We are specifying that it should be coming from protocol direct, and then we advertise loopback 0, which is the system IP. Once you've done that, you need to activate, use this policy in our BGP configurations. So with this, we should now be able to advertise the loopback IP of this device towards the ASBR. So let's go to P1, run the commands. Let me just ensure this one doesn't time out. On P02, we'll do the same. We want to advertise 1.1.1.7/32. We want to advertise it to the ASBR2 so that it's propagated across the network. So these are similar commands, just a change of the IP that we are advertising. So I'll go to P02, run the commands. Now, if you are to check on SBR1 and SBR2, we expect that we should be having these prefixes. If you show router BGP routes and you specify that label IPv4, you will see that we have this prefix here, 1.1.1.2. So we have the loopback here and it's ready to be sent to the remote device. On SBR2, we can do the same. Show router BGP routes, label IPv4, you will also see that we have 1.1.1.7. So they are already advertised to the SBR. We are now waiting to advertise them to the remote SBR. So SBR1 should advertise it to SBR2. SBR2 should also advertise 1.1.1.7 to SBR1. And then those routes will be propagated to the remote PEs, and then we can test the reachability. So step 6, we need to configure eBGP LU. So for option C, we need to establish BGP peering session between the SBRs. In option A, we did VRF to VRF. In option B, we did VPN v4 peering between the SBRs. In option C, we establishing eBGP label unicast peering session between the SBRs. So you need to ensure that you have the family label IPv4 specified in your BGP configuration, and then you should be able to establish this label unicast session between the SBR. So I'll configure on SBR1. Then on SBR2, we are doing the same. Just remember that it's label unicast, so you need to specify that family. So once you've done this, show router BGP summary. We expect that we have a session established, a BGP LU session established. That's why you can see here it's labeled IPv4 established between the SBRs. Now we have bridged the gap. Remember, we did not have the routes advertised from SBR1 to SBR2, but with the BGP LU, we can now verify whether the routes are being advertised. So you show router BGP routes, label IPv4, and you can see that we are having this prefix propagated to this node. When you check on SBR1, show router BGP routes, IPv4, it's labeled IPv4, you see that the routes have been propagated. So now the routes have crossed the boundary between the two ASs. If you go to P1 and show router BGP routes, label IPv4, you will see that now we have the loopback of P2. It has propagated across the two ASs. And once we have this loopback in this routing table, we can now establish VPN v4 peering between the PEs. If you go to P2, show router BGP routes, label IPv4, you see that we also have this prefix propagated across the network. So we are good. We can now go ahead and establish BGP VPN v4 peering between these different devices in the different autonomous system numbers. We can try to ping 1.1.1.2. You see that it's reachable on P1. If you show router route table, you see that 7.7.7 is also installed and it's tunneled. It's coming in with a BGP label. You can ping 1.1.1.7. Remember, this is the IP address that we'll be using to establish BGP session between these different routers. So we need to ensure that it's reachable from either end, from P1 to P2, from P2 to P1. The next step, we need to establish VPN before peering between PEs. Remember, in option C, the peering can either be between the remote PEs, or for scalable solution, you can have route reflectors implemented in the network. So this is a very straightforward configuration. We are just establishing VPN before peering between PEs. One important command that you need to remember is the multi-hop. Remember, BGP will establish eBGP session only one hop away. So for us to ensure that this session will be established, we need to increase the number of hops. Remember the TTL value. So we need to increase the number of hops depending on the number of connections that you have in the network. You can set it to 2, you can set it to 5, depending on the network that you are managing. But without this command, the BGP session will not be established. So you need to ensure that you have the multi-hop command configured. And then you have the family. We are specifying the family as VPN IPv4. So the session, the BGP session type established between the PEs will be for VPN IPv4, so that they are able to establish the BGP session and exchange the VPN routes between them. I'll copy these commands, go to P1 and configure them. And then we'll do the same for P2. Once you've configured this session, you can show router BGP summary. You will see that now we have VPN v4 session established between the PEs and a label IPv4 session established towards the ASBR. On P1, we can also show router BGP summary, and you will see that we have a session established, the label IPv4, the label Unica session established towards ASBR01, and now we have a VPN v4 session established towards PE02. So we have completed the configuration that are required to ensure that we have BGP session established between the remote PEs in different ASs. Now we need to go ahead and implement the VPN instances, or the VPRN, on PEs, and also configure the CEs. For this, in step 7, we are configuring VPRN on PEs, and we also need to bind the interfaces to the CEs. So you configure VPRN. We are using VPRN 100. Name, we call it VRF1. And then we need to configure the route distinguisher. We are using type 1 route distinguisher, and the VRF targets. Remember, these will help to control the route export and import between the different nodes. Once we've completed this part, we need to configure the interface. So we are configuring interface to C1 and give the correct IP address and bind the correct port and the SAP, the service access point. So on P1, I'll copy these commands and apply them. And we'll do the same for PE2. So for PE2, we also do the commands. You can show router 100 interface. You see that we have an interface to C2 on P1, show router, VPRN, show router 100 interface. You will also verify that we have this interface configured towards C1. The next step is we need to establish eBGP session towards the CEs. Remember, we are using eBGP as our PECE routing protocol, so we need to establish BGP sessions, and this BGP session should be configured under the VRF or the VPRN 100. So I'll do the commands On P1, these are similar commands that we've been using in the previous session to implement option B and option A. Then I'll do on P2, if you show router BGP summary, you'll see that we don't have that peer specified because we need to show router 100 BGP summary. And you will see that we have a session, but it's in the connect stage. It's still trying to establish TCP connection. The next step, we need to configure CEs. So for CE configuration, very straightforward. We need to configure the interfaces, and then we need to export. We are creating a loopback 50.50.50.50 to simulate a customer network. So we need to import this prefix into BGP and advertise it towards the remote CEs. And then we do the BGP configurations. These commands, we've already explained them in the previous session, so I will not explain them again. So I'll do C1, run the commands. And then for C2, we also need to do the same. I'll copy the commands, go to C2 and run them. Now you can show router BGP summary. You will see that we have BGP VPN P4 session established on C1, show router BGP summary. You also have a session IPv4 established. On P1, if you run the command show router 100 BGP summary, you expect that you have IPv4 session established towards C1. Now, once you've done this, remember that we want to propagate the routes. So we need to configure PEs to advertise received VPN P4 routes to the CEs. If you are to check the routing table of PE, show router 100 route table, you will see that we have these prefixes 50.50.50 and 60.60.60, which is coming from the remote CE. But if you go to the CE, show router route table, you will realize that we don't have 60.60.60 because the PE is not advertising the received VPN v4 prefixes to the CEs. So that's why we need to configure this policy to help us to advertise these prefixes from the remote PEs should be advertised to the local CEs on the network. So we'll use this policy, again, a very straightforward configuration that we've used in the previous sessions. Then on P2, we'll do the same, just to ensure that PEs are able to advertise these prefixes to the local CEs. And then once we've done this, we can do the verification again. If you do show router route table, now you see that we have this prefix 50.50.50. Then if you check on this other end, show router route table, you see that we also have the prefixes. They have been propagated from the remote CEs to the local CEs. So we have these prefixes. Remember, we have VPN before. So the local PE will advertise the route to the remote PE through the VPN v4 peering session that we've established. And once those routes have been advertised to the remote PE, they can now be advertised to the local CEs, and then we'll have the connectivity. So we can do ping 60.60.60.60. You see that we have the connectivity. This is local CE. So if we do 50.50.50, you realize that it's not going through. The reason is we need to source. So if you source 60.60.60.60, you will see that we have connectivity established between these different nodes. So this one confirms that our option C implementation is working okay, and we can now have end-to-end communication through our in the AS option C configuration that we've done. So it may be complicated, but it's very easy to understand. You just need to do the step-by-step configuration, do the verification, and confirm that everything is okay. So that is it for this session. Again, I hope you will check out other trainings that are available on this training platform. We have HCI training course that will help you to prepare for your HCI certification. We have the Huawei HCI dams that will help you to respond to questions correctly, to help you analyze the question and respond to them correctly. We have Huawei Lab Simulation. We also have the Nokia Lab Simulation that will help you to understand how to implement different protocols on Huawei, on Nokia, and also on Juniper. If you want to learn about the IPRAN technology, you can also check these different videos that will help you to understand IPRAN technology and how you implement it on a service provider network. Thank you so much for watching this session, and I hope to see you in the next episode. Bye.